Welcome back to school, grade 9. This is a video that I'm doing for grade 9. This would be considered our lesson number 1. I just want us to have an opportunity to continue our learning, and so what I'm going to do occasionally is put a video on that would offer something for you to listen to and study and get a chance to do some practice so your brain can stay fresh for math. So we're going to get right into it and start with a bit of a review so that we can remember what we were doing before we left for this month-long time off of school. And so if you remember, we were working on N3, which was being able to add and subtract, multiply and divide with rational numbers, so with fractions and decimals and whole numbers and integers. And so today I'm going to just get us kind of going with a few questions that would be on your N3 target. So if you want to pause this video and run and grab your N3 targets, if by some weird chance you had them home with you, then absolutely by all means go grab them. Or if you just want to use this video to help you remember where we were before we move into N4, which is where you take all of those different operations on rational numbers and put them into one question. So BEDMAS with fractions and decimals and so on. And so we're just going to jump right in, and I'm going to put some questions. Yes, I have a chalkboard in my kitchen. It's bizarre, I know. Normally there's a decorative something up there on the chalkboard. Before today it said spring is here, but I'm going to use it for a learning opportunity for you guys. So if you have a piece of paper and you want to write that down, you're also going to need your calculator. Maybe you're going to use your phone as a calculator because your calculator's in your locker. That's fine. So let's try this one. So hopefully you're all prepared with a piece of paper and you can take a second and copy that down. Okay, so if you remember correctly, when we're trying to figure out what some numbers are that are between a couple of different rational numbers, and you remember rational, I tried to explain what the difference was between a rational number and an irrational number. Rational numbers make sense, and irrational numbers don't make any sense. In fact, the actual definition of a rational number is that it can be written as a fraction, and the definition of an irrational number is that it couldn't be written as a fraction. And so if you think about it in terms of that, all of the numbers that I have up here on the board all could be written as fractions. And so these are all examples of rational numbers. And so if I'm looking at finding a number that lies between 0 and -1, then a lot of times what I would do is I would start by creating a number line. So I'll do that. And of course, if it's a negative number, then the negative number has to go on the left, and you know, your 0 is going to be here on the right. And so when I'm thinking about this, oftentimes what I will do is I will think about it in terms of money, especially when it has to do with negatives. That's often a way that I can look at it. But I use money as an example for a lot of these in my own mind. So between a 0 and a -1, if it was something that I have borrowed $1, let's say, from my brother, then I think, okay, well, If I start paying him back, let's say I find 50 cents lying in the cushions and I can give him back 50 cents. Well, then how much money do I still owe him? I still owe him 50 cents, right? And so that's a number that's in between. And so that would be one answer. Now, a lot of times, one of the methods that I like to use is when I start comparing decimals, I like to make sure that my decimals all have the same number of digits after the decimal point. And so when you look at 0 and -1, you think, well, they don't have a decimal. So what do you mean by that? Well, I can add a decimal and put the zeros there, and of course it doesn't change its value, and that might make it a little bit easier for me to be able to compare. And so I'm going to add decimal 00 to both of these different numbers, just so that it makes it a little bit easier in my mind to compare them and say, okay, well, as long as they have the same number of decimal or digits after the decimal, it makes it a little easier for me to say, I understand where 50 goes in between the 0.00 and the -1.00. Hopefully that makes sense to you. Okay, and the next one, if I'm going to take a 1/4 and a 1/5, what we recommended doing and what we were doing before this break is that we were taking 1/4 and we were turning that into a decimal. And so do you remember how to do that? So you're going to want your calculator. I'm using my phone. And remember that 1/4, this is the same thing as a division question. So 1 divide by 4 is how I would turn that into a decimal, and so that's going to end up being 0.25. And then when I do the same thing with 1/5, that's going to be 0.2. And this is a perfect example of how, if I don't have the same number of digits after the decimal, sometimes it makes it hard to compare. So some people would look at this and they would say, well, 2 is less than 25. And you would be right. You would be right. But for a different reason. Think about this in terms of it being 20 hundredths instead of 2/10, because the 25 is in hundredths. So it's 0.25. If I turn that into a fraction, I'm thinking 25 hundredths. Okay, so that would be easier to compare to 2/10 if I make it into 20 hundredths. So just adding a 0 doesn't change the value of that, and it makes it a little bit easier for me to compare and say, okay, well, this one's bigger. Now, the question was actually not necessarily which one was bigger, but what is the number in between. Still makes it easier for me to compare by saying, okay, 0.20 and 0.25, well, I can tell you that 0.21, 0.22, 0.23, those are all numbers that are in between. And we talked about this as well. How many different answers are there between 0.2 and 0.25? And I can just hear some of you saying right now, infinite. There's an infinite number of numbers that are in between 0.2 and 0.25, because truthfully, you could keep adding those zeros to the end and you could go on and on forever. And so, I could have someone who says, oh, well, here's a number that's in between 0.20000000001. And they would be right, wouldn't they? They would be absolutely right. But just to keep it easy today, I'm just going to pick a number 0.21. So that's in between. And again, negatives, -0.7 and -0.8. When you look at that at first, you might think, well, there are no numbers in between those two. But the truth is that there are numbers in between those. And the easiest way for us to do that is to add the zeros to the end, and then we can compare them. Oops. So now if I think about it like money again, if I have 70 cents that I owe to someone and I have 80 cents that I owe to someone, in between that was 71 cents of debt, 72 cents of debt. And so if I think about that, writing that as a number, it would be 0.72, 0.73, and they would all be negative. How many different answers are there in between? There are tons of different answers in between. Okay, so that got us started. We're going to move on to adding and subtracting in this video. So I'm just going to pause this for a second while I wash off my chalkboard, and then we'll continue on with the second part of this lesson. Okay, so we're going to continue on. You'll notice that this question says number 4, but you think, well, did I miss something? No, you didn't. If you did go and get your N3 targets, then you would notice that I left out numbers 2 and 3 in this video just to move on and keep things simple. The point of this opportunity for learning is not to overwhelm you. It's to give you something that you can do to help you feel like when you come back to the classroom, whenever that might be, that you have not lost all this time, but instead you've been doing something that's keeping your mind fresh and helping you to feel like you're still moving forward, so that the math and the literacy, science, and social studies is still there and still quick for you to recall. So that's kind of the point. It's not meant to overwhelm you. So please don't let this video make it feel like, okay, I have to get this done before a certain amount of time. No, that's not. Just work away at your own pace and let me know when you are ready for something new. Okay, so when we're talking about adding and subtracting, this first question is asking us to add and subtract fractions, and in order for us to add and subtract, there's a common error that happens, and I can just think of it now. Many students make this error. They just start adding the top and the top, and then they start adding the bottom and the bottom, and we can't do that for many different reasons. First of all, before we start to add them, what do we have to do? We have to get a common denominator. I wish I could hear your little voices right now, but anyway, we have to get a common denominator. So a lot of times when I look at the question like this one, and I say negative 3/5 plus a 2/3, I oftentimes will have students who will say, listen, I find this difficult to find the lowest common multiple between a 5 and a 3. And in this particular case, it actually wouldn't be terribly difficult if you think about it like this. Take the 5 and multiply it by the 3, and take the 3 and multiply it by a 5. And in this particular case, that actually would be the lowest common multiple. But that's a good strategy that a lot of kids like to use. It's consistent. It works every time. So you can do that with all of these questions, where you can basically multiply the denominator on one side by the denominator on the other side, and make sure that you do it both to the top and to the bottom. Otherwise, what we're doing is we're creating something entirely different. And if we multiply the top and the bottom by the same number, then all we're doing is creating an equivalent fraction. And we haven't really messed with the question. We're just manipulating it in such a way that allows us to be able to add them better. Okay, so if I take this 5 and I multiply it by 3, and then I times the top by 3 as well, I'm going to have negative 3 over 15. And then if I times this one by 5 and this by 5, then I end up with 10 over 15. Okay, so the next common mistake would be that someone would take the negative 9 and add the 10 and get the positive 1, but then they would take the 15 and add the 15 and get a 30. But keep in mind, whenever you're doing all of that to get the common denominator, you're going to keep that common denominator. So you're just going to add the tops and you're going to keep the bottom. So negative 9 plus 10 ends up being a positive 1, and then you keep the 15. Somebody might say, well, would it be okay for me to use a calculator, turn this all into decimals? And generally I would say that's not a problem. But in this particular case, if you take a negative 3 and divide it by 5, you're going to end up with a negative 0.6. That's great. But when you take the 2/3 and you divide that and turn that into a decimal, you're going to end up with a repeating number, 0.66 repeating. And so what ends up happening is a lot of kids will say, I better just round that 0.6 repeating off to 0.6. And so when they take a negative 0.6 and they add a 0.6, they'd end up with an answer of 0. But we know that the answer isn't 0. It's 1/15. And although 1/15, if you were to use your calculator and figure that out, it's going to end up being 0.06 repeating. That's not the same thing as 0. I know it's awfully close. And you think, does it really matter? It does matter. I mean, the older that you get, the more important it is to be precise, right? When you were younger, it was okay to round some of that stuff off, and especially if you were just estimating, that was fine. But the older that you get and you move into some of these other courses, you're going to need to make sure that you're being precise. You can imagine if someday you had a job in a bank and you started rounding off those numbers, maybe they wouldn't catch it the first time, but if you did that if that was your strategy every time, and you're dealing with client after client after client, and you keep rounding that stuff off, it's not going to be long before you've lost lots and lots of money, and then you're probably going to end up losing your job. So it's important for us to realize that those digits do matter. So I'm asking you to keep this as a fraction in order for you to be able to add and subtract them. And when something's given to you in decimal form, go ahead and keep it in decimal form if you want to. So the next one right here, this would be an example of how you could take, well, first of all, we need to take this, what's known as a mixed number. It's a mixed number because you got whole numbers and fractions right alongside each other. We're going to turn those mixed numbers into improper fractions. So, and you probably remember how to do this. You take that whole number and you multiply it by the denominator. So 2 times 8, which is going to give you 16. And then you add the numerator, so that's going to be 21. And then you keep the same denominator of 8. Okay? And then let's do the same thing over here. I'm just going to leave this. I know that there are some of you who are probably writing this down right now and you're thinking, okay, but I see the negative and the negative side by side. I'm going to go ahead and turn that into a positive. And you absolutely can do that right now if you want to. I'm going to go ahead and leave it the same way and try to focus on just this first step of changing my mixed numbers into improper fractions, but you can do it the other way if you want to add that in as well. So 1 times the 2 plus the 1 is going to be 2. 3, keep the 2 as my denominator. Okay, now can I go ahead and add 21, subtract, the, and how did I end up putting that on the outside? Look at that. You're going to watch me like a hawk. Where's that supposed to be? That's supposed to be in there, isn't it? Can I just go ahead and add the 21 plus the 3, or 21 subtract the negative 3? No, I can't, can I? What do I have to do first? In these questions, I have to make sure I have a common denominator. And so if I wanted to use that same strategy that I used in the other question, where I times the 8 by the 2 and the 2 by the 8, I could get a common denominator of 16. And for those of you who are thinking, listen, I just want one strategy, give me one strategy and I'm going to use it over and over again, that might be for you. But there's also the students who are sitting there saying, why would I bother messing with the fraction on the left when I can just get a common denominator of 8 by timesing that denominator of 2 by 4, and then I'll end up with 21 over 8. Go ahead and take those two negatives and turn it into a positive, and that's 12 over 8. (21) plus 12 is equal to 33 over 8. Now, I bet you there are those of you who are wondering, is it important for me to take that improper fraction and turn it back into a mixed number? And the answer is no. But if you wanted to, then you could. What would it end up being? Well, think about how many times 8 would go into 33, and it would go 4 whole times. And there'd be how much left over? Well, 8 times 4 is 32. 33 take away 32 is 1. So if you wanted to, you could write that as 4 and 1/8. But here's the truth. You don't have to do that unless it tells you specifically. That's not necessarily considered simplifying it. Okay, so you can just leave it as 33 over 8 if you'd like to. Okay, so then the next ones are really, what we're going to be doing is we're going to be using our calculator to be able to solve these. And so if I think about using my calculator, really, and quite frankly, there are going to be those of you who are thinking, well, I can just do this in my head. And I am very happy that there are some of you that can just do this in your head. But if there are those of you who are still struggling with being able to do that in your head, then we're going to move along and figure out ways and strategies that are going to help us to be able to be successful in math without getting bogged down with mental math. That's not really what we want to do at this point in your math career. You're all in grade 9 and you're moving into grade 10 next year, and we want to find solutions for you to be successful. And so we're going to use our calculator today. So let's take a look. If you have your phone, then by all means use your phone, or if you actually happen to have your calculator home, then that's great. But 5.7, and then for me, my second button in on the left is my negative sign, so negative 5.7, and then I'm going to subtract 3.2, and so my answer is a negative 8.9. Some people might remember that in one of the packets that you received, we talked about how a negative 5.7 is the same thing as, when you subtract 3.2, that's the same thing as adding a negative. And so for some people that kind of helps them, because they think, well, oh, that makes sense to me, because again, we go back to money, and I think, okay, well, 5.7, if I borrowed $5.70 from someone, then I turn around and borrow more, $3.20, I owe that person a total of $8.90, which is of course the answer. And when I look at this next question right here, this one reminds me of this other question, but with bigger numbers. And so again, we're just going to use our calculator, and you're going to say 52.9, put in your negative sign, and then you can add 17.4, subtract, put the negative sign on, and then you have a negative 70.3. You can do it that way, or what would be the other way that you can do it? These questions are very similar, aren't they? So if you wanted to, you could go negative 52.9, subtract 17.4, because that positive and negative that are side by side are going to end up becoming a negative. And so you could also write that like this. And then, of course, we just said that the answer was a negative 70.3. Okay, well, you've made it through, a 20-minute video or so. And honestly, if you think about what Dominic Carty, who is our Minister of Education, is recommending, is that you end up with about 2 to 2.5 hours of work a day. And this is your math. I'm going to leave you with a couple of questions here that will take you probably somewhere between 5 to 10 minutes to do. And if you wanted to take and send those to me as an email, I would check them over for you, not because it's going to be worth a mark. It's not. None of this is going to be worth a mark. You don't have to worry about that. But I know that some of you will want feedback. Did I do it right? Can you help me figure out where I went wrong if I didn't do it right? And I absolutely will do that for you. So if you wanted to take a picture of it and send it back to me, then I would do that. So this is what I'm going to ask you to try. And so if you would give that a try and then send it to my email, I'm going to just write my email up here. And please know that you can get on our Microsoft Teams page. There's a page that's dedicated to specifically our class that you and I can communicate with each other on, and I've already got it activated. So if you're happy to see this video, and if you happen to be seeing this video and you have not received an email from me, please fire off an email and I will make sure that I add you to that list so that we can make sure that we're communicating as best we can. Again, please stay safe, stay healthy. Don't let this overwhelm you. Just allow it to be something that will put your mind on something positive that's moving you forward in the right direction. And I will hopefully talk to you soon. I'll be posting another video as soon as I see kind of how well received this is and how many people are interested in them, and then I'll move along. All right, folks, see you later.